Hello friends, Kannur University MSc Physics Entrance Examinde Model Question Paper Discussion ബാക്കി വീഡിയോ ആണിത്. We have already uploaded up to question number 25. So let us start our discussion with the 26th question. Which of the following is wave number corresponding to first line of Balmer series? Wave number is given by 1 by lambda equal to RH into Z square into 1 by NF square minus 1 by Ni square. Here Rydberg constant RH is equal to 1097371, which is approximately equal to 1 into 10 raised to 7 per meter. And for hydrogen Z equal to 1. To find orbital number, we know this is n equal to 1, n equal to 2 and n equal to 3. ഇവിടെ ചോദിച്ചിട്ടുള്ളത് ഫസ്റ്റ് ലൈൻ ഓഫ് ബാർമർ സീരീസ് ആണ്. Therefore from 3 to 2. That is NF equal to 2 and Ni equal to 3. Therefore wave number equal to Rydberg constant 1 into 10 raised to 7 per meter. Z is 1 here and 1 by 2 square minus 1 by 3 square, which is approximately equal to 0.15 into 10 raised to 7 per meter. Option A is correct. Question 27. If A is an observable, the uncertainty delta A is defined as uncertainty of an observable A is given by delta A whole square equal to expectation value of A square minus square of expectation value of A. Option B is correct. Question number 28. A particle is constrained to move along x-axis in a region 0 to A, have a wave function n sin pi nx by A, where n is an integer and the value of normalization constant is given. Wave function psi x equal to n sin pi nx by A. Condition for normalization of a wave function is given by integral minus infinity to plus infinity psi into psi star x dx equal to 1. Here limit is from 0 to A. Therefore integral 0 to A psi into psi star n square sin square pi nx by A dx equal to 1. N square can be taken outside integral 0 to A. We know sin square theta equal to half into 1 minus cos 2 theta. Therefore half can be taken outside 1 minus cos 2 pi nx by A dx equal to 1. N square by 2 into integral 0 to A 1 dx minus integral 0 to A cos 2 pi nx by A dx equal to 1. That is n square by 2 into integral 1 is x minus sin 2 pi nx by A into 2 pi nx limit 0 to A. Apply limit, we will get n square by 2 into A minus sin 2n pi minus sin 0 equal to 1. Sin 2n pi is 0, sin 0 also 0. Therefore n square by 2 into A equal to 1. From this n equal to root 2 by A. Therefore option B is correct. 29. Which of the experiments support spin angular momentum? Answer is Stern-Gerlach experiment. Option B is correct. ഓപ്ഷനിൽ തന്നിട്ടുള്ള എക്സ്പെരിമെൻറ്റ്സ് ഒക്കെ ജസ്റ്റ് ഒന്ന് നോക്കാം. Stern-Gerlach experiment demonstrated that the spatial orientation of angular momentum is quantized Thus, an atomic scale system was shown to have intrinsically quantum properties. And in this experiment, they used silver oven. Frank Head's experiment is a direct evidence of quantized energy states in an atom as given by Bohr's postulate. ബോസ് മോഡൽ ഓഫ് ആറ്റത്തിൽ പറയുന്ന ക്വാണ്ടൈസേഷൻ ഓഫ് എനർജി പ്രൂവ് ചെയ്യുന്ന എക്സ്പെരിമെൻ്റ് ആണ് ഫ്രാങ്ക് ഹെഡ്സ് എക്സ്പെരിമെൻറ്റ്. ഇവിടെ യൂസ് ചെയ്യുന്നത് മെർക്കുറി വേപ്പറാണ്. ഡേവിൻസൺ ജർമ്മൻ എക്സ്പെരിമെൻറ്റ് പ്രൂവ് ദ wave nature of electrons and the de Broglie relation through diffraction of electron beam by nickel crystal. And Michelson-Morley experiment was to detect the velocity of Earth with respect to hypothetical luminiferous ether medium. But the result was negative. Ether exist ചെയ്യണില്ല എന്നാണ് മൈക്കിൾസൺ-മോർലി എക്സ്പെരിമെൻറ്റ് പ്രൂവ് ചെയ്തത്. Question number 13. Value of spin magnetic moment of electron. Consider an electron revolving around a nucleus of radius r with velocity v. The magnetic dipole moment of revolving electron is given by mu equal to half EVR. Multiplying by m, we will get mu equal to EL by 2m, where L is angular momentum which is equal to mvr and m is mass of electron me. From Bohr's atomic model, we know L equal to nh by 2 pi. For a single electron atom, value of n is 1. Therefore, L equal to h by 2 pi, which is equal to h cross. Therefore, mu equal to EH cross by 2 me. This is the minimum magnetic dipole moment of an electron, which is called Bohr's magneton. Represented by mu b. നമ്മളിവിടെ കൺസിഡർ ചെയ്യുന്നത് ഒരു സിംഗിൾ ഇലക്ട്രോൺ ആറ്റാണ്. ആൻഡ് വാല്യൂ ഓഫ് mu b is equal to 9.27 into 10⁻² ആംപിയർ മീറ്റർ സ്ക്വയർ. Bohr magneton is the magnetic moment of smallest magnet. Smallest magnet എന്ന് പറയുമ്പോൾ that is electron. Option C is correct. Question number 31. The ground state energy of an electron in one-dimensional infinite square well having 1 angstrom width. Energy of a particle in one-dimensional infinite potential well is given by En equal to n square h square by 8 ml square. Here En is equal to, for ground state energy n is 1 and value of h is 6.63 into 10⁻³ whole square divided by 8 into mass of electron is 9.1 into 10⁻³ into width of the well is 1 angstrom, that is 1 into 10⁻10 meter square. ഇത് കാൽക്കുലേറ്റ് ചെയ്യുമ്പോൾ നമുക്ക് 6.031 into 10⁻80 ജൂൾ എന്ന് കിട്ടും. ബട്ട് ഇത് ഓപ്ഷനിൽ ഇല്ല. Question 32. If the density of liquid drop is same throughout the volume, the corresponding assumption is called. For an incompressible liquid, the density remains constant throughout the volume. We know compressing something means applying pressure to reduce the volume so that the density of material increases, bringing the molecules even closer to each other. Here density is same throughout the volume, therefore it is an incompressible liquid. Option D is correct. Question 33. What is the spin of O70 nucleus in its ground state with conventional unit? To calculate spin of an atom, we usually use this method. That is, when number of proton is even and number of neutron also even, then value of I is 0, that is no spin. If number of proton is even and number of neutron is odd, or number of proton is odd and number of neutron is even, in this case value of I is an half integer. That is I may be half or 3/2, 5/2, etc. When both number of proton and number of neutron are odd in number, then value of I will be integer number, that is I equal to 1, 2, 3, etc. ഇനി ഇതെങ്ങനെ കാൽക്കുലേറ്റ് ചെയ്യാമെന്ന് നോക്കാം. ഫോർ എക്സാമ്പിൾ 6C12, there will be 6 proton and 6 neutron. എല്ലാ പ്രോട്ടോണും ന്യൂട്രോണും പെയർഡ് ആണ്, ഈവൻ നമ്പേഴ്സ് ആണ്. Therefore I will be 0. For C30, there will be 6 proton and 7 neutron. പ്രോട്ടോൺ എല്ലാം പെയർഡ് ആയതുകൊണ്ട് തന്നെ അവിടെ സ്പിന്ന് 0 ആയിരിക്കും. ബട്ട് ന്യൂട്രോണിൽ ഒരു അൺപെയർഡ് ന്യൂട്രോൺ ഉണ്ട്. Therefore there will be half spin. So total spin is half. And value of spin may be 0, 1/2, 1, 3/2, etc. up to 7. But we cannot calculate all the value of spin using this method. Some atom spin is determined experimentally. For example, sodium 11Na23, which have spin 3/2, and 8O70 have 5/2, 17Cl35 3/2. ക്വസ്റ്റ്യനിൽ ചോദിച്ചിട്ടുള്ളത് O17 ആണ്, വിച്ച് ഈസ് 5/2. Therefore option D is correct. Question number 34. Nuclei having comparatively longer excited state is called as. We know that the excited state is unstable due to extra energy. That is excited സ്റ്റേറ്റിലേക്ക് പോകുന്നതോറും സ്റ്റെബിലിറ്റി കുറയാണ് ചെയ്യുക. Therefore here suitable answer is option D, none of this. ഇതിൽ ബാക്കിയുള്ളത് നോക്കുമ്പം ഐസോമറിക് ന്യൂക്ലിയ വിത്ത് സെയിം അറ്റോമിക് നമ്പർ ആൻഡ് അറ്റോമിക് വെയ്റ്റ് ബട്ട് ഡിഫറെൻറ്റ് ഇൻറ്റേർണൽ സ്ട്രക്ചർ. Hypernuclear, a nucleus which contain at least one hyperon in addition to the normal proton and neutrons. 35. The Q value of reaction is minus 4.0362 mega electron volt. What is the threshold energy of the reaction? Given a nuclear reaction with Q value minus 4.0362 mega electron volt, and this reaction represents that fluorine is being bombarded with neutron and produce oxygen by emitting proton. ഒരു പ്രൊജക്റ്റൈൽ വന്നിട്ട് ഒരു ടാർഗറ്റ് ന്യൂക്ലിയസിൽ തട്ടുന്നു and produce a daughter nucleus and some particle is emitted. In this reaction, small letter a is projectile or bombarding particle and this is target nucleus, thereby produce a daughter nucleus. This is residual or outgoing particle. In this reaction, threshold energy is given by ETH is equal to minus Q into kinetic energy of projectile plus kinetic energy of target nucleus by kinetic energy of target. Or we can write minus Q into mass of projectile plus mass of target by mass of target. Here we use this equation since kinetic energy is not given. Therefore given reaction is as neutron is projectile and fluorine is target nucleus, produce oxygen, that is daughter nucleus, by releasing proton. So here threshold energy equal to minus Q into mass of projectile, that is mass of neutron plus mass of target by mass of target. Q value is given minusum plus ആവും, therefore 4.0362 into 1 plus 19 by 19 which is equal to 4.26 mega electron volt. Option B is correct. 36th question. Moderators are using for. In a nuclear reaction, moderator is used to slow down the neutrons produced from fission. ഒരു ഫിഷൻ റിയാക്ഷൻ കൺസിഡർ ചെയ്യുമ്പോൾ ദർ വിൽ ബി ഫാസ്റ്റർ ന്യൂട്രോൺസ് ആൻഡ് സ്ലോവർ ന്യൂട്രോൺസ്. ഈ സ്ലോ ആയിട്ട് പോകുന്ന ന്യൂട്രോൺസ് ഫിഷൻ റിയാക്ഷന് കണ്ടിന്യൂ ചെയ്തു പോകും. ബട്ട് ഫാസ്റ്റർ ന്യൂട്രോൺസ് ടെൻഡ് ടു അബ്സോർബ് ബൈ സർട്ടൻ ഐസോട്ടോപ്സ് ഓഫ് യുറാനിയം അതുകൊണ്ട് തന്നെ ഫിഷൻ റിയാക്ഷൻ നടക്കാൻ വേണ്ടിയിട്ട് അവരെ സ്ലോ ഡൗൺ ചെയ്യാനാണ് മോഡറേറ്റർ യൂസ് ചെയ്യുന്നത്. സം എക്സാമ്പിൾ ഓഫ് മോഡറേറ്റർ ഈസ് ഹെവി വാട്ടർ ആൻഡ് ബെറിലിയം ഗ്രാഫൈറ്റ്. ഇതൊക്കെ മോഡറേറ്റർ ആയിട്ട് നമുക്ക് യൂസ് ചെയ്യാം. ഹിയർ കറക്റ്റ് ഓപ്ഷൻ ഈസ് ബി. Question 37. Which of the following is a possible reaction? First reaction is given here. Let us check the conservation of charge. Charge of neutrino is 0 plus 1 0. Positron charge 1. Therefore ഇത് രണ്ടും ഈക്വൽ ആയതുകൊണ്ട് തന്നെ ചാർജ് ഈസ് കൺസേർവ്ഡ്. ബട്ട് ലെപ്റ്റോൺ നമ്പർ കൺസർവേഷൻ നോക്കുമ്പോൾ ന്യൂട്രിനോൻ്റെ ലെപ്റ്റോൺ നമ്പർ ഈസ് 1 plus 0 0 minus 1. Lepton number is not conserved. Therefore this reaction will not occur. Option A incorrect ആണ്. And also option D കൂടി നോക്കുക. ഓപ്ഷൻ എയും ഓപ്ഷൻ ഡിയും സെയിം ആണ്, രണ്ടും ഇൻകറക്റ്റ് ആണ്. ഇതാണ് നെക്സ്റ്റ് കൊടുത്തിട്ടുള്ള റിയാക്ഷൻ. അതിൻ്റെ ചാർജ് കൺസർവേഷൻ നോക്കുമ്പോൾ ന്യൂട്രോണിൻ്റെ ചാർജ് 0, പ്രോട്ടോണിൻ്റെത് 1 പ്ലസ് പോസിട്രോണിൻ്റെ 1 പ്ലസ് 0. So charge is not conserved. Option B യും incorrect ആണ്. So we can say that option C is correct here. Question number 38. If the quantity e raised to hv by kt minus 1 is less than 1, which of the following statement is correct? Given that e raised to hv by kt minus 1 is very much less than 1, we know this quantity indicating the ratio of spontaneous emission to stimulated emission, which is less than 1. So it is clear that stimulated emission dominate over spontaneous emission. Therefore option B is correct. 39. There are 5 into 10 raised to 28 atoms per meter cube in copper. The value of Hall coefficient is. Hall coefficient is given by RH equal to minus 1 by Ne, where N is number of charge carriers per unit volume. Here N is given by 5 into 10 raised to 28 and E is 1.6 into 10 raised to minus 19. ഇത് ചെയ്യുമ്പോൾ നമുക്ക് minus 1.25 into 10 raised to minus 10 meter cube per coulomb എന്ന് കിട്ടും. Option B is correct. Question number 40. What is the Miller indices of a plane parallel to z-axis and intercept of 2 and 3/2 along x and y axis respectively? Given x and y intercepts made by a plane parallel to z-axis, that is x intercept is 2, y intercept is 3/2 and plane is parallel to z-axis. Therefore this is 0. We want to find Miller indices. We know Miller indices are defined as the reciprocals of the fractional intercept which the plane makes to its crystallographic axis. So given fractional intercepts, ഇതിൻ്റെ റെസിപ്രോക്കൽ കാണുക, that is 1/2, 2/3, 0. എല്ലാത്തിനെയും 6 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ 3, 4, 0. This is the Miller indices. So answer is D. 41. The value of rotational constant for diatomic rotator is. The question is about rotational constant of diatomic rotor, and here the condensed rotational energy of diatomic molecule is given by Ej is equal to h square 8 pi square I into j plus 1. This energy is in joules, and where h is Planck's constant, I is moment of inertia, that is mu r square, mu is mass of molecule, and j is rotational quantum number. We know energy is equal to hc by lambda. From this, wave number 1 by lambda is equal to E by hc. So we can write this energy in terms of wave number. Epsilon j equal to Ej by hc, that is h by 8 pi square I into c j into j plus 1 in centimeter inverse. Here This is called rotational constant B. So we can write energy in terms of wave number epsilon j equal to Bj into j plus 1 centimeter inverse, where B is equal to h by 8 pi square I into C. So this is the answer. Option is C. Question 42. A cyclotron of maximum radius 0.25 meter accelerates proton in 2 Tesla magnetic field. What is the frequency of applied voltage? In cyclotron, centripetal force is equal to Lorentz force, that is force due to magnetic field. Therefore, mv square by r equal to qvb. From this, velocity v equal to qbr divided by m. We want to find frequency mu equal to v by 2 pi r. Therefore, divided by 2 pi r on both sides. Now we will get mu equal to qb by 2 pi m. Use this equation. Mu equal to charge of proton is 1.6 into 10 raised to minus 90 coulomb. Magnetic field is given 2 Tesla divided by 2 into 3.14 into mass of proton is 1.67 into 10 raised to minus 27, which is approximately equal to 10 in the power calculate ചെയ്യുമ്പോൾ 10 raised to 18 കിട്ടും. And 1.6 approximately 1.5 5 ആക്കി എടുക്കുമ്പോൾ 3 by 2 into 2 divided by 2 into 3.14 3 1.6 again 3 by 2 ആക്കി എടുക്കാം. 2 will be cancelled and 3 will be cancelled. 1 by 3 is 0.3 into 10 raised to 8, that is 30 into 10 raised to 6 hertz, which is equal to 30 megahertz. Therefore, correct option is option A. 43. Wavelength of helium neon laser in visible region. The helium neon laser operates at the wavelength of 632.8 nanometer in the red portion of the visible spectrum. Helium neon laser is the most widely used gas laser. Here answer is option C. 44. A piston cylinder contains air at 600 kilopascal at 290 Kelvin with volume 0.01 meter cube. A constant pressure process gives 54 kilojoule of output or work. Find the final volume of the cylinder. Here given that pressure P is equal to 600 kilopascal, which is constant, and initial temperature 290 Kelvin, initial volume 0.01 meter cube, work done is 54 kilojoule. We want to find final volume. We know that work done is equal to integral P dV. Therefore, W is equal to P into change in volume is V2 minus V1. From this we can write V2 is equal to W by P plus V1, that is 54 kilojoule by 600 kilopascal plus 0.01 meter cube, which is equal to 0.1 meter cube. This is the answer. Option B is correct. ഇനി ക്വസ്റ്റ്യനിൽ ഫൈനൽ ടെമ്പറേച്ചറും കണ്ടുപിടിക്കണമെന്നുണ്ടെങ്കിൽ we can use PV is equal to nRT, where P is constant, nR is constant. From that we can write T2 by T1 is equal to V2 by V1. So using this equation we can find temperature. Question number 45. The pressure of a gas in terms of its mean kinetic energy per unit volume E is. Mean kinetic energy of a gas per mole is given by E equal to 3 by 2 nRT, and for ideal gas PV equal to nRT. Here we want to find pressure per unit volume. Therefore, P equal to nRT. From this we can write nRT is 2 by 3 E. Therefore, pressure per unit volume is 2 by 3 E. Option B is correct. Question 46. If certain amount of dry ice is mixed with same amount of water at 80 degrees Celsius, the final temperature of mixture is. The given mixture contain water at 80 degrees Celsius and ice at 0 degrees Celsius. Here the amount of water and ice is same. Assume that x gram of water and x gram of ice. ഇവിടെ ടെമ്പറേച്ചർ ഹൈ ആണ്. Therefore, this temperature will be decreased into 0 degree Celsius by releasing some heat energy. That is, x gram water at 80 degree Celsius is converted into x gram water at 0 degree Celsius by releasing some heat energy. ഈ ഹീറ്റ് എനർജി ഉപയോഗിച്ചിട്ട് ഇവിടെയുള്ള ഐസ് വാട്ടർ ആയിട്ട് മാറും. ഫ്യൂഷൻ വിൽ ബി ടേക്സ് പ്ലേസ്. ദാറ്റ് ഈസ് x gram ice at 0 degree Celsius is converted into x gram water at 0 degree Celsius by absorbing some amount of heat energy. Here the heat loss by hot body to change the temperature is given by Q equal to ms delta T. Let it be Q1. Q1 equal to mass is x gram and specific heat of water is 1. Change in temperature 80 degree Celsius 0 degree Celsius ആവാൻ 18 ആണ് delta T. Therefore, 18x calorie will be released. Energy required to phase transfer is given by Q equal to ml, Q2 equal to ml, and which is equal to mass is x gram and latent heat of fusion is 80 calorie per gram per degree Celsius. Therefore, 80x calorie energy is required for fusion. Here, this releasing energy is completely used for the fusion. So, there is no excess amount of energy. Here, finally, x gram water and at 0 degree Celsius ഉണ്ടാവും. ഇവിടെ നിന്നും x gram water at 0 degree Celsius ഉണ്ടാവും. Therefore, total 2x gram water at 0 degree Celsius will be there and excess amount of energy Q1 minus Q2 equal to 0. ബാക്കി എനർജി ഒന്നും ഇല്ലാത്തതുകൊണ്ട് തന്നെ there will be no further change in temperature. Therefore, final temperature is 0 degree Celsius. Option A is correct. In case ഇവിടെ കുറച്ച് എനർജി ബാക്കി ഉണ്ടായിരുന്നെങ്കിൽ that is Q1 minus Q2 ഒരു 10 ജൂൾ ബാക്കി എനർജി ഉണ്ടായിരുന്നെങ്കിൽ ഈ 10 ജൂൾ ഇവിടുത്തെ ടെമ്പറേച്ചർ കൂട്ടാൻ ഉപയോഗിക്കും. ദാറ്റ് ഈസ് Q ഈക്വൽ ടു ms ഡെൽറ്റ ടി. ms ഡെൽറ്റ ടി ക്യാൻ ബി T2 മൈനസ് T1. ഈ ഇക്വേഷൻ ഉപയോഗിച്ചിട്ട് നമുക്ക് ഇവിടുത്തെ ഫൈനൽ ടെമ്പറേച്ചർ കണ്ടുപിടിക്കാം. ഇൻ ദിസ് ക്വസ്റ്റ്യൻ ദർ ഇസ് നോ ബാലൻസ് എനർജി. ദെർഫോർ ഈ ടെമ്പറേച്ചറിന് ചേഞ്ച് ഒന്നും ഉണ്ടാവില്ല. 0 ഡിഗ്രി സെൽഷ്യസ് തന്നെ ആയിരിക്കും ഫൈനൽ ടെമ്പറേച്ചർ. ക്വസ്റ്റ്യൻ നമ്പർ 47. Minimum work in compressor is possible when the value of adiabatic index gamma is equal to 1. Option B is correct. Question 48. The more effective way to increase efficiency of Carnot engine is. Efficiency of a Carnot engine can be increased by two methods. That is, by increasing high temperature or by decreasing lower temperature. Here, decreasing lower temperature is more effective way to increase the efficiency of a Carnot engine. Therefore, option D is correct. 49. A cylindrical rod of length L and cross-section area A is rigidly fixed at its upper end and hangs vertically. If Y is the Young's modulus, the elongation produced in the rod due to its own weight W is. Here a rod is hanged vertically like this. The length of rod is L and cross section area is A, weight is W and Young's modulus is given. The elongation produced in the rod is given by WL by 2AY. Option A is correct. Last question. 50. The attenuation of the 3-section RC phase shift oscillator is 1/9. Option B is correct. ഓക്കെ, ഇത്രയും ക്വസ്റ്റ്യൻസ് ആണുള്ളത്. PG എൻട്രൻസിൻ്റെ പ്രീവിയസ് ക്വസ്റ്റ്യൻസ് അവൈലബിൾ ആണെങ്കിൽ അത് വെച്ച് പ്രാക്ടീസ് ചെയ്ത് നോക്കാം.